In today's video, we are going to see about Cloud Vision API. So as soon as you go into the Google Cloud platform, go to API and services, and click on library, and go to Cloud Vision API. So you have to enable this API for the project that you're working on. So click on enable, and then as part of the enablement, it'll ask you to create a service account uh, which you will be using for authenticating your application to use Vision API services. So let's go to a different project and see how Cloud Vision API is enabled there. So I'm going into another sample project, and here I click on enable. It will take some time to get enabled. Okay, so once it gets enabled, all you have to do is go to IAM services, IAM and admin, go to service accounts, and then create a new service account. So I have already created a service account in my Vision API project, and to this service account I have given the role of AI platform admin to access the Vision API services. So now let's go to the AI platform, click on notebooks, so click on new instance, a Python 3 instance, and here you can give your name for your Jupyter Notebook instance, and then if you want to change the region, you can change it, and you can decide on the custom subnetwork that you want to deploy this notebook, and then click on create. So as soon as you click on create, it will create an instance with a link to its Jupyter Lab notebook. So click on that, and it will open up a new tab, and here you can create your Python notebooks. So I have already created a notebook to use the Vision API services. So let's go ahead and see the contents in this notebook. So as I stated earlier, I had created the service account, and for that service account I have created a key. I downloaded the key to my local machine, and then I re-uploaded this to this notebook instance. And I also have a sample image called smile.jpg. We are going to detect the image in this smile.jpg file, and we're going to see whether we are able to detect the face and the joy likelihood for this image. So let's see how to do that. So first thing is you import the Vision library. So from google.cloud you can import the Vision package, and then you import CV2, Matplotlib, import OS packages, and then let's go ahead and visualize the image. So using CV2, I read the smile.jpg image and then convert it from BGR to RGB channel, and then I display it using Matplotlib. So this is the image, and in order to provide this input image to the image annotator client, I have to give that either as a either as an URI link or content with stream of bytes. So there are only two options available. Either you can place the JPEG file in a cloud storage bucket and then pass that link to this image annotator client, or you can read that image file as a stream of bytes and then feed that content to the image annotator client. So I read the image as a stream of bytes. I opened that image file and then I read them as a stream of bytes. And then the next thing is we have to set the credentials path so that this notebook instance can authenticate to the CloudVision API service. The next is the function that we define our image annotator client. So under the Vision-Pack library, we have image annotator client, and inside this client, we have multiple client options. So using CloudVision API, we can detect phases, you can detect landmarks, you can detect explicit content. So there are a variety of usages that you can do using the image annotator client. You can also detect OCR, object character recognition, through image annotator client. And we pass on this stream of bytes to the face detection function, and then we get a response back from the Vision API. And we go through the response content and get the joy likelihood and the vertices of the face detection. So it can detect multiple faces in an image file, and we can iterate through each and every facial response. So we take the face annotations from the response JSON file, not the JSON, from the response JSON, and we iterate through each of those phases. And here we have to declare a list, a tuple. Sorry, it's a tuple with the various likelihood states: unknown, very unlikely, unlikely, possible, likely, and very likely. You have to follow the exact format for this tuple. So it has to be, the unknown should take the first value, and then it goes with very unlikely, unlikely, possible, likely, and very unlikely, very likely. So, and then I iterate through the phases, and here you get the likelihood name from the numerical value of the joy likelihood. So say for example, we got very likely because the image in the picture, she's joyful. So it has recognized, the CloudVision API has recognized the mood of the image in the person. So and then it has given a numerical value of 6, and the corresponding values taken from the likelihood name tuple list. And we also got the vertices of the image, and we use those vertices to draw the rectangle on the image. This is written using the OpenCV package. So you can use the function of cv2.rectangle to annotate the image with a rectangular box. And you can also add a text to that image using cv2.putText. And we have got the joy type from the face annotations, and we have added them to the image. And once you have added them to the image, you can finally display it. So so this is how you can use the CloudVision API to do object detection on images. So let's also go through the pricing for CloudVision API. So as you can see here, it can do a varieties of features. It can do logo detection, facial detection is what we did now. It can do facial detection of celebrities. It can do landmark detection, web detection, object localization. A lot of other features that are available in Cloud Vision API. And for every 1,000 units, you're not charged. You get it free of cost. But after 1,000 images, after 1,000 units, you will be charged $1.50 for every 1,000 units from then on. So, and it gets reduced after you surpass 5 million images. So I would say if you have if you have a need to detect images less than 1,000, I would say you can go with Cloud Vision API. It can do a series of various types of detections, and you can make utilize of that. And if you want something out of the box, but I think this actually has a very high price tag for usage of units above 1,000. So I would say try to create a custom model and then deploy it into a as an deploy it as an endpoint, and then use that endpoint for detecting the images. So I think that would be much better whenever you want to detect images in frames. In frames, detect images in frames of the video content. Then I would say better go with a custom model rather than using this Cloud Vision API. But anything of less usage, then you can go with the Cloud Vision API. So, thank you.